Hello, my name is Fakhri Maharamzadeh, and this is Practical Work 3, Variation 30, based on the LibriNet public library scenario. In this video, I will explain what MongoDB is and how I used it in this practical work, how I imported the data using MongoDB Compass, how the database is structured, and I will explain one advanced aggregation query in detail. So what is MongoDB? So MongoDB is like a document-oriented NoSQL database. Instead of like storing data or in tables and like rows like relational databases, MongoDB stores information as documents like in a JSON-like format called BSON. This structure is flexible because documents can include nested objects and arrays, which makes MongoDB suitable for hierarchical data models. And MongoDB is also efficient for analytics with data is with when data is like denormalized because related information can be embedded inside the one document and queried with aggregation pipelines. So the scenario is like in this scenario is a library network has historical data stored in separate files such as loan logs, book catalog data, and member registry, like member registry data. And because the data is fragmented, the library services team cannot like easily analyze overdue trends and popular genres or like late fees. So my goal in this practical work was like to migrate this data into MongoDB, correct the data types and like create a denormalized analytics collection, then perform advanced aggregation queries for reporting insights. Database structure is like and collections like I created a database called LibraryDB. Inside it, I created three collections, like books that contains reference information about books, like such as genre, author, and publication year. Members that contain reference information about library, members such as age, join date, or like home branch uh like uh I mean publication year. So the home branch is contained in members, that is like information about library members such as age, join date, and home branch, yeah, again. So loans contains like transactional data such as checkout dates, return dates, and late fees. After importing, I corrected like data types because many numeric and date fields were imported as strings. Then I created a denormalized collection like called loans and changed, which embeds both book details and member details into each loan record, and also includes a calculated duration field. So I also used MongoDB Compass to connect to the local MongoDB instance using a local host connection. Then I created the database library DB and created the three collections like books, members, and loans. For each collections, I used like the Compass import feature to import the corresponding JSON file. After import, I verified the collections and confirmed that the values such as dates, ages, years, and fees were stored as strings, which is why task tree is necessary before performing analytical queries. Task 3 and 4 overview. So here we have for task 3, I perform data type correcting using update many with converting strings into correct types such as int 32, double, and data. I used on error and on null to prevent the script from failing if any values is missing or invalid. And I denormalized the data into like loans and changed using an aggregation pipeline. Like I joined books into loans using lookup and unwind. And I also joined members into loans. Then I calculated loan duration days using dative. Finally, I used out to write the result into the new collection. Thank you for listening.